Okay, so I will be presenting my first video session on this subject microcontrollers and embedded systems. As I've already told, uh, three regular classes will be taking in the class itself, and one will be online. So where I'll be covering certain portions of that particular modules. So here today in this session, I will be extending regarding the bus and memory of the ARM. Okay, so we have seen that ARM is basically a microprocessor or a microcontroller. It can act as both, and it is being used for designing of the embedded systems. It's a major component in the embedded system. So with respect to that, we have been working towards the hardware architecture of the embedded system using ARM. And I will go back to that architecture again. And in that today's session, I will only pick up two components. One is the bus of the ARM, how bus is being used, or what is the composition of a bus, and what all the memory that comes in the embedded system, which is designed with ARM. Okay. So first, let us share the screen. 1 second. Yeah, entire screen. Yes, embedded system hardware. This is where we have stopped in the regular class based on the ARM. I told that the very first component is the ARM processor. And when processor is in execution, interrupts may happen. Interrupts might come from the external devices to signal that they want the attention of ARM, memory, or the hard disk and other things. So to manage that, if there are multiple interrupts, we use something called as interrupt controllers. Apart from that, this ARM is getting connected to one of the component called as memory. Memory can be in the form of static RAM, flash RAM, or dynamic RAM on the rightmost side. And that day I told that if you want to connect processor and the memory, you have to use bus. Bus in itself is a very simple collection of copper wires, and that form a bus. There are two types of bus that we are going to use. Between the processor and the memory, we use a high-speed bus. Between the processor and the peripherals, which is the input and output devices, we use a low-speed bus. Here, specifically, the bus used between ARM processor and the memory is called as AHB, ARM high-speed bus. So, if multiple devices or multiple requests comes to the processor for the bus, but in the bus only one request can be serviced. Therefore, what we have to do, we have to go for something called as arbiter. So arbitration, its task is to see that only one who has to be given the access to the bus. If multiple requests for the same bus comes, only one person has to be authorized. Who is that? That arbiter will decide. AHB arbiter. And then you cannot directly connect to the RAM. So there is a bridge which we have to pass, which is called AHB external bridge. And once again, memory can be accessed by many people. There can be a concept of shared memory. So who has to be given access is being controlled what is by a software called as or a hardware called as memory controller. That is the top portion. Then ARM processor not only speaks with memory, ARM processor also speaks with peripherals. Peripherals are in simple terms the input and output devices. But if you want to reach the peripherals, it has to go through a bus called as APB, ARM peripheral bus. But there is no direct ARM peripheral bus connection. You have to first go through high-speed bus itself. From there, you have to pass through a bridge called as AHB APB, where your speed will change. And from then, you can reach all your peripherals. So that in the previous class I have discussed, there can be a real-time clock, there can be UART devices, there can be Ethernet network controller, or it can be the counters and timers, which can all act as peripherals. They're all input and output devices. Fine. Now let us study more about this bus, because there are two types of bus, AHB and APB. Actually, one more type of bus is there, which is internally used. Just like college bus, we use from college to the outside world. Within the college also, some small vehicles will be there. to carry on the people and to carry on the luggage, to carry on the goods and other things. So there will be one more bus inside. Internally, one bus will be used. Externally, one bus will be used. So let us see all those details in the next component. Also in this session, we'll be discussing on various types of memory and their impact. Let us go to the next point. Bus technology. See, ARM uses what is known as a RISC architecture. But this bus technology in the olden days, different types of bus was used, particularly in the older architecture called x86, and the bus that was used was called as PCI. If you open the older computers, particularly the x86, all your Intel, which runs on x86 architecture, they were using a bus called as PCI. They were not using the ARM bus concept, they were using something called as PCI. PCI is the older alternative for ARM. What is PCI? Peripheral Controller Interface. Peripheral Controller Interface. This is an old one which is used in the x86. All your Intel processors communicate with x86. And why you are using bus? Because we want to interconnect our motherboard or the processor board to hard disk drives. Hard disk drive, all your hard disk will be attached to that drive. Or even video cards, graphical cards and other things you want to interconnect. So from processor, you want to interconnect the hard disk drives or the video cards. We were using a bus called as PCI bus. You can see the various slots here, the white color slots in the motherboard. This is a complete PCB of the motherboard, and various slots are available for connecting. And this bus is external or off chip. That is, the component which you are interconnecting is not inside. So since it is mainly the microprocessor based architecture, this x86, all your hard disk drives as well as the video cards, they will all be outside the chip, external. So the bus will go to the external or off chip. It is not a part of the chip. This is older alternative. This is not ARM. The exact opposite will be the ARM. Okay, let us see that. ARM bus. Basically, it is not used in computers. Unlike the previous architecture I showed is your classical computers, where there is a motherboard PCB where all your processor, bus, everything gets connected, and to the hard disk drives or to the video cards or to the other peripherals it is connected, the PCI architecture, and it is an external or off-the-shelf architecture. Whereas ARM bus, which we are using, is mainly for embedded devices. It is majorly a microcontroller that is useful for embedded devices than the computers, desktop computers. And it is used to interconnect different peripherals with the ARM core. The ARM core processor will be there. From the processor, you want to interconnect the peripherals. Peripherals means input devices and output devices. You want to interconnect, we use ARM bus. Along with that, memory is also connected. And since it is majorly a microcontroller, it is internal or on the chip. It will be inside. The bus will be inside the things. External cable will not be there. The bus is inside, internal. This is the major difference between ARM bus and PCI bus. PCI bus is external or off chip, and the external cable you have to connect. Earlier we were doing microprocessor lab where we were using a bus cable separately to connect to the peripherals. Peripherals may be the LED stepper motors or LEDs or many other things, LCDs and other things, CROs. But now it is internal. This bus is internal. It is in the chip. Inside the chip itself, you will have it. Okay, that is about the first point related to the ARM bus, the comparison with the PCI. Second, the ARM bus architecture. The architecture of ARM bus. It employs an architecture called as master-slave architecture. Now you can observe this figure. This person who is giving the instruction is a master, and whatever he says, they are simply following it, trying to do it. Whatever instruction he gives, they will simply do that. I think classically what happens in civil engineering works, there will be a masonry kind, subcontractor or contractor. There will be workers. He will simply tell, okay, do these things. That much they will do. That's it. So whatever work is given, they will do only that much. They will again not cross question much. Here also, master slave is a pure concept where only masters can dictate, masters can instruct. And these slaves have to respond. They will not initiate. Whenever they get instruction, they will follow it. Like that, ARM bus also follows the master slave. Next important question to be answered: who will be the master and who will be the slaves? See, ARM bus is used between ARM processor and the peripherals. So peripherals will be the slaves and ARM processor will be the master. So master is the ARM core processor who can initiate the data transfer, who will tell what to do, which will instruct the data transfer. And slaves are the peripherals that are that is capable of responding to the transfer request. It will tell you transfer from there to there. These slaves have to respond and do it. That's all. Only instructions are given by master. Exactly, it is followed by slaves without any question, without any delay, without any failure. They have to do it. That's all. Okay. So such a simple architecture is followed by ARM bus, which is master slave, where our ARM processor is the master and peripherals are the slaves. Now, what are the different levels of architectures we have in ARM bus? The first architecture is the electrical architecture. The levels means how you can express the ARM bus architecture. The first one with respect to which you can explain the ARM bus architecture is electrical level. Electrical level means what are the electrical characteristics of the bus, means how much data it can transfer and other things. Once again. Yeah. Electrical characteristics of a bus means a bus is a collection of electrical cables, copper cables we told. So what is its insulation property? What is its resistance property? What is the conductivity property? How much data it can transfer? How much voltage it can sustain? All these things will come there. Next, what is the bus width? The bus width means the size of the bus, whether it is 8-bit, whether it is 16-bit, whether it is 32-bit. It depends on how much data it can carry. So whether 32-bit data it has to carry or 16-bit data it has to carry. That is the width of the bus. So the physical properties of a bus, we call it as electrical and bus width, is one way of expressing the architecture level of a bus. So based on the electrical characteristics, levels can be defined, or based on the bus width, levels can be defined. Okay, that is one property. Second thing is the slide that is being shown. You can see that those two people are communicating with each other. Actually, it can be seen as a communication quarrel. Both of them trying to speak at the same time, both of them trying to put their point, and that is where the conflict has arisen. So therefore, any communication should follow a protocol. If protocol is not followed, then such situations happen. People here, the communication protocol is between the processor and the peripherals. If that is being not properly followed, if multiple requests are not properly arbitrated, problems can happen. Failures can happen. Data transfer may not happen. All these things will happen. Therefore, the second way of expressing the architecture level is the protocol between the processor and the peripherals. See, any protocol will work when there is a communication. Now, here is a communication between the ARM bus and the ARM core processor and the peripherals. So when processor wants to speak with peripherals, there is a communication, there is a protocol to be followed. The protocol is very simple. Since it is master slave, processor will dictate the information to the slaves. Slaves will respond and then send the response back to the processor. That's all. Request response. Instruct and response. You can say instruct and response. So a protocol, communication protocol exists between the peripherals and the processor. Next. So this is our AMBA bus architecture, which is ARM bus architecture, AMBA and the ARM bus architecture. This is a summary of all the discussion we had so far. As you can see that at the left side, what we have is the ARM here. So ARM is connected to all types of memory, whether it's RAM or DMA or external memory, through a bridge through a bus called as AHB. The bus used between ARM and memory is AHB. If it is external memory or AHB. Internal memory or internal communication means we will use ASB. Okay. So there can be two types of memory communication from ARM. It may communicate with the external world or external memory, which may be SRAM, DRAM, DMA, external memory, hard disk, and other things. For that, they use AHB, ARM high speed. But for some of its tasks, it has to do internal communication. It will use ASB, ARM system bus. Processor matta internal memory. Small part of the memory used for internal communication. Internal workarounds, internal interrupt processing, like that. It is not external, it is internal. So adike they use a bus called as ASB. So finally, with memory and ARM, either AHB or ASB is used. Next comes peripherals on the right side. Peripherals may be UART, it may be a timer, it may be a keypad, it may be a PIO, like that. It can be anything. Whatever may be the peripherals, if you want to communicate, you have to go through a bus called as APB, ARM peripheral bus, which is low speed. APB, AHB difference on that. AHB is ARM high speed. APB means ARM peripheral bus, which is low speed. But however, ARM cannot directly have APB communication. Only it has is AHB. Then there comes a bridge, AHB APB bridge, which will switch from AHB to APB. See, highway and ghat section. Bus cannot go at the same speed. Highway, high speed, AHB. But once you enter ghat section, you should be extra careful. Particularly if steep ghats are there, you should be very, very careful. Then you have to control. Go slowly, drive slowly, like that. There we use APB, ghat sections only. Or if the road is not a good thing, you have to go for APB. You have to change the gears and do that. But other highway and other places can go where the road supports it, we can use AHB. Same thing happens here. Peripherals only we use APB, memory only we use AHB or ASB. So going through all these jargons here, ASB stands for ARM system bus, which is for internal communication. AHB and ARM high performance bus. Bandwidth is 64-bit or 128-bit. High bandwidth, high speed and and one more thing is there called multi-layer AHB, means instead of single bus, because you know that one bus and only one request will get serviced. You can have multi-layer bus. You can have multi-layer, flyovers. Like that. Or one more layer you make flyover. One more, 3 levels people can travel. Or double-decker bus you might have seen. People can sit down also on top also. Like that, multi-layer AHB means you can have multiple requests at the same time. Parallel. And if you don't want 64 or 128, you just need a shorter bandwidth, say 32-bit or 16-bit. You can use the version called as AHB Lite. You need not use the high-speed AHB. You can go to AHB Lite based on if the request is very small. The bandwidth required is very small. Next. Then comes APB, which is ARM peripheral bus with slower bandwidth. New, changes that has happened is AHB new interconnect supports multiple processors supporting operations in parallel. Okay, that is what going on. Yes, that's about bus. Okay, so with respect to bus, you are expected to know the types of bus, the architectures of bus, and how it connects. This diagram could be helpful. And all those terminologies will be helpful. These points like the character, physical and software, logical architectures, and master-slave concept you have to write. Maybe one direct question you may get, explain ARM bus, describe ARM bus. All these points should be covered. Then comes what is known as memory. As you can see, there is a brain. People are trying to load a lot of information. And all this information it is containing is called as a memory. In memory only we can keep everything. Okay. See, for example, if you imagine yourself, so many events inside the college, classroom events or outside events, friends. go up somewhere else, family information, everything gets registered inside memory. Memory is a place where everything goes inside. Okay, all the information is coming inside the memory. So embedded system needs memory to store. Why memory is required for an embedded system? First of all, what is the need of memory? Okay, how to connect ARM and memory we have seen using the high-speed bus. Next question comes, why you need memory in context of embedded systems? Why memory is required means they will store and execute the code. Your program has to be kept inside memory and the execution happens inside memory. Okay, so memory is required to store and execute the code. See, the different types of memory they have told. Even in the class I have discussed. So we have registers, and then we have cache, we have main memory, and then we have secondary memory, like that. Here registers are kept separate. So other three types of memory we have is cache memory, main memory, and secondary storage. So the fastest is cache, as I told that day also in the class. You can imagine your bag itself is a cache. So whatever data you want, if it is in the bag, is fastest. If it is not there, you have to search that room, which can be main memory. Room allo illa andre you have to go outside and see whether it is there, and that is external memory. So inside the room, in the bag, you first search, which is cache. Alli illa andre in the room somewhere it will be there, which is main memory. If it is not in the room, you have to go outside, which is the external or secondary storage. So here, as can be seen, there are two factors to be considered. In terms of size you are speaking, memory size, definitely cache has a very less size. Bag size is smaller compared to the room size. Room size is smaller compared to the outside world. Outside, corridor, staff room, everywhere else. On the room in the organ, it can be anything. So largest memory is secondary. Next is main. The least size is cache. So cache size is in terms of MB, whereas secondary storage will be around GB, TB, like that you will have. Okay. If you are talking about the speed or the performance, definitely cache is having the very good performance as per the graph. X-axis size is there. Size is increasing. Cache size, if you compare, main memory size is completely more than that. And even more is secondary storage. The size is increasing in terms of the x-axis. In terms of y-axis, we have performance. You can see that performance is declining. Means the speed is declining. Cache is fastest speed. So if you don't get in cache, you have to search main memory, or the speed will be less. So you require a lot of time to get it. More time is required if the data is in secondary storage. To search something, if it is in cache, fastest. If you don't get, definitely more time is required in main. More time is required in secondary storage. So performance degrades with respect to the three types of memory. Next. So storage trade-offs, we call. Trade-offs means the problem is if you gain something, you're losing something. And if you are trying to gain with size, you'll be losing with speed. If you are trying to gain with speed, you are losing with size. So if you are trying to gain one by losing another, this property is called as trade-off. Here, you're gaining the size but losing the speed. Other way also, right? That is the trade-off. Next. So based on the instruction, how many cycles would be required? It depends on the size of your memory. If your memory is a very small memory with 8-bit size, and you know that there are two types of instructions. Normally, all the ARM instructions are 32-bit. Since ARM follows RISC, all the instructions are 32-bit. But that day we discussed that ARM is not just RISC, it is an advanced RISC, and it has some changes. So ARM has a special register called as thumb registers, which support 16-bit instructions. Thumb registers allows 16-bit instructions. So basic ARM instructions are all of 32 bits. But if you want 16-bit registers, we can use thumb instructions, or thumb registers can be used. Now, based on whether your instruction is 32-bit or 16-bit, you can find out how many cycles are required. If it is 8-bit, then definitely 4 cycles are required. 32-bit again, 4 times you have to go. 4 cycles, 4 times you have to go, because you want 32-bit, but memory is only 8-bit. So first go and get 8-bit. Then once you get it back, again go and get back 8-bit. Then go and get back 8. 4 times you have to go and bring. Okay, because your memory is only 8-bit. If it is 16-bit, then twice you have to go and come. Twice. First so 16-bit, I'm at 16-bit. 32-bit only one time if you go and come, it is sufficient. One cycle. Going and coming is called cycle. So going to the memory and getting it to your register is called as cycle. ARM processor in the memory back to register. This is one cycle. Our memory 8-bit you have to take 4 times you have to do this cycles. 16-bit 2 cycles. 32-bit means 1 cycle. But instead of that, if the instruction itself is 16-bit, then for 8-bit, 2 times you have to go. 16-bit 8-bit one time, 8-bit another time. If your memory itself is 16-bit, only one time you have to do. But if your memory is 32-bit also, 1 cycle only. It does not really help us. Thumb instruction is 16-bit memory is sufficient. 32-bit memory, same performance as 16-bit. Okay. So this is the impact of memory on the instruction cycles. Memory size also impacts. If memory is very short, too many cycles. Memory is larger, less number of cycles, faster execution. Ilana, you'll be spending time in computation itself, going, bringing, like that itself. You'll be spending the time. Okay. So memory should be more. Next. Okay, let us just explore through the various types of memory which we have. The very oldest type of memory is ROM. ROM indicates read-only memory. You can only read it, you can't write it. Okay, so it's a permanent storage. Usually some boot code or OS or some initialization code is kept inside ROM. When your OS is getting booted, some initialization code is kept inside the ROM. You can't edit the ROM. It is read-only. Yeah. It's permanent. Read-only, permanently set during production time. And when they are preparing ROM itself, and it cannot be reprogrammed. You cannot change the program and reload it. Once you write it, it is finished. You can't edit the same hardware. Mainly some boot code. Boot code means some initial instructions before the OS gets loaded. Before you load your OS, environment has to be ready. That environment readiness is dictated by boot code. Okay. Memory should be reorganized, some hardware should be started. All those things should happen before our OS starts booting. That code we call it as boot code. It's very short. Tomorrow again in the class I'll explain, because there is one topic on that boot code. Okay. But where you keep boot code is ROM. Right. So this is about ROM, which is permanent, which cannot be changed, written in the production time itself, and what it contains, mainly the boot code. Next. Instead of ROM, the problem with the ROM is you cannot change it, they are telling. But time and again, if the ROM gets corrupted and you want to change it without replacing the ROM, there is one more option called as, instead of traditional ROM, or a conventional ROM, go for a flash ROM. Mobile phones, you might have heard flashing concept. Flashing on the factory reset, it will wipe away everything and reload the things. So you cannot edit actually, but you can replace it again, rewrite it again, complete resetting is called as flashing. So flash ROM is one such thing. Andra, it is same as ROM, but it can be edited, but not exact intermediate editing. You have to completely rewrite. That kind of editing is possible. Can be written but slow. That flashing is very time consuming. It will take hours together. Dynamically, time and again you cannot keep on changing it. It's not as RAM. RAM is dynamic. Same dynamic nature never you will get in flash ROM. Flash ROM, complete OS, complete boot code is reloaded. That's all. Not OS, complete boot code is reloaded. The Haladella, it will remove, erase, That is one process. Again, it will rewrite with a new thing. If any virus or any other checksum errors are there, it will be solved. So it is very slow, not for dynamic data, suitable for firmware data. That is, firmware is a device where it will have hardware and software both. Such boot code again is used in flash ROM. Erasing and writing of flash is software controlled. How to do this flashing? There is a software for that. Flash Magic anta one software is there, or some HR anta there is a software. So it is software controlled. That is flashing. That is reloading the complete ROM is software control. There is no hardware for that. There is a software control. So definitely, compared to the complete static nature of ROM, this is little dynamic in that it can be rewritten, but it has to be completely rewritten. It has to be erased and written. That is only option possible in flash ROM. It is not dynamic. It cannot be changed intermediate. And how to do this? It is software control. And what it contains, same as ROM, it contains the boot. Again, boot code. Then since it contains the boot code and they contain the thing that cannot be changed, we need some space which keeps changing for all our applications. All our applications require memory, and that memory is RAM, random access memory. I think all of us know very basic about RAM. RAM is volatile. That is, it will immediately, all the data you write on RAM is erased once we switch off or boot off the system. System shutdown ಮಾಡಿದ ತಕ್ಷಣ the entire RAM gets cleared and it will start reloading once we boot again. Two types of RAM exist: static RAM and dynamic RAM. The difference is the nature, why it is called static and dynamic. To maintain dynamic RAM, it should be refreshed again and again. So there will be a circuitry that keeps refreshing it again and again. Refresh button in the OS to refresh the dynamic RAM. Otherwise, it will not work. It will simply, the space gets accumulated and you will run out of RAM again and again. So to maintain that, it keeps refreshing again and again. Static RAM refreshing is not required. It is not required. It manages itself. No refreshing circuitry is required. However, static RAMs are costlier compared to the dynamic RAM. So dynamic RAM is cheaper than static RAM, and dynamic RAM is slower as it requires the refresh than the static RAM. What you will store is anything, any data, any variables, any information required in the program, everything can be stored in the, and your executable code, everything can be stored in the RAM. The program in the executable code. Program when it runs is called process. Process is stored inside the static RAM as well as the dynamic RAM. So last part of our discussion today, there is one special RAM called as SDRAM, which is in between static RAM and dynamic RAM. SD, the static dynamic RAM, synchronous dynamic RAM. Here refresh rate is required with dynamic RAM because the clock speeds may vary. This type of RAM will synchronize itself with the computer clock. This type of a RAM, dynamic RAM, will synchronize itself automatically with computer clock. No refresher circuit is required. Refreshing is still required, but that is automatic. But no external refreshing mechanisms or clock pulses are required. It will automatically synchronize itself with the computer clock. So special RAMs are called as synchronous dynamic RAM. So dynamic RAM itself, but it can run at much higher clock speed than the conventional dynamic RAMs. It synchronizes itself with computer system clock. This makes it easy to manage faster. Okay. So this was about memory discussion. See, memorially, why we use memory in embedded system? To store and execute the code. Code will be stored. And if you compare, there are three types of memory, and there is a trade-off in those three types of memory: cache, main memory, secondary memory. So in terms of size, least is cache, highest is secondary. In terms of performance or speed, cache is fastest and external or secondary memory is slowest. That is one figure. Second, the size of the memory impacts the instruction cycles. Again, there are two types of instructions. Conventional ARM instruction, 32-bit. Thumb instruction, special, which is 16-bit. So if 8-bit memory is there, 4 cycles, 16-bit memory are there, 2 cycles, 32-bit memory are there, 1 cycle for the 32-bit instructions. Other 16-bit, half will be taken. After that, we have discussed the various other types of memory, like, ROM, what ROM contains and what is its drawback. Other flash ROM, better than ROM. It can be erased and rewritten. And if you want a pure dynamic nature, go for RAM, static RAM and dynamic RAM, and the special one, synchronous dynamic RAM. Still, static RAMs are very costly and most of the computers do not afford it. So the people still use dynamic RAMs, and even a better alternative is synchronous dynamic RAM, just to improve the speed of access. Okay. So many questions might come within this, explain the different types of memory, or explain storage trade-off. Okay, like that. So I think that is about this class. Right. Just go through this. Any doubt is there at any point, note it down and just ask me. I will tell you. I'll explain you again. No problem. Okay. So tomorrow class, I will start with peripherals. We have seen ARM bus and memory today. Next, we will see peripherals, because ARM bus is used between ARM processor and memory. So memory part we have seen. Next is between a processor and another component is peripherals. We'll discuss on peripherals. We'll discuss on the interrupt controllers, memory controllers, and the embedded software. All those things tomorrow we will see. Thank you.